Hello and welcome to my video, lesson 7.4, solving exponential equations using logarithms. All right, so let's take a look at these questions a little bit more carefully here. We have a few to solve. And so what can we do to solve these sorts of questions? Well, first of all, we can just use the simple-ish method where we move stuff around and try to solve it using a calculator. So first of all, this might be straightforward enough. If we remember that we have the base, we have the exponent, and that equals the answer. Well, if we transfer it into a log form, then we would have log base of the answer equals the exponent. So it's kind of just rearranging things a little bit to make them work. So in a very simple version, we can take this question and we can switch it to log 3 of 27 equals x, and we can't plug that directly into our calculator, but we can plug in log 27 over log of 3. So this is the one method, but what else could you do? So this is rearranging. What if you wanted to use kind of opposite operators and do this more algebraically, I suppose? Well, what that would look like is if we took this question and we took a log of both sides. So just like in any algebra, if you do something to one side, you have to do it to the other. So if we do this, we end up with this sort of equation. And then what we can do is we can move the x down using our power law from the last unit, or last topic, 7.3. And so now we're left with this. And then what we can do is we can take our log of 3 and move it over to the other side, log of 3. And so now this goes to x equals log 27 over log of 3. So either way is actually the same answer, and that shouldn't be surprising. Assuming both methods work, they should be the same answer. And now we can just plug it into our calculator. So log 27 bracket divided by log of 3 end bracket equals, and this equals 3, which we should be able to do just by looking at it. It would be pretty simple to do as well. So we can also just try this out ourselves. Go 3, or let's try it this way. 27 divided by 3 equals 9. Divided by 3 equals 3. So how many times does the 3 show up? 1, 2, 3 times. So the answer for x equals 3. So now I've just shown you 3 different methods to solve this simple question, but it gets a little bit more complicated later. So if it isn't a nice whole number, the blue and orange method won't work. So for the next question here, blue and orange method won't work. Purple method and red and green method, Christmas method, will both work for the rest of these questions, but this unit, or this topic specifically, is looking more at the red and green. So we're going to work on the red and green method, which I think it becomes a little bit more helpful, especially looking at some of the later questions here. So let's try the red and green method from now on. So what that would look like is that we take a log of both sides, so log of x to the, 5 to the x, log of 100. Now what's really nice here is that if we have log of 100, we actually know the answer straight away. And so anyways, we can now take the x and put it out front. So log of 5, log of 5. And log of 100 is just 2 because if it's base 10 and you have 100, you can just count the number of zeros, 1, 2 zeros. So it's 2. And then what we can do is divide by log 5 on both sides. So it's 2 over log 5. You could also have, at this point, you could still have the log 100 up here. That's also perfectly fine. But because I recognize that it's a 2 right away, it's just as easy to leave it like that. So anyways, 2 divided by log of 5, and that is 2.86. And there's more decimals afterwards, but we're going to leave it there. All right, so that one is pretty good. Let's take a look at the next question here. We're going to take a log of both sides. Actually, before I continue, please try out these 2 questions on your own and see if you can get to the answer before I do. Okay, so log of both sides. So log of 6 to the x, log of 20. And so now what we can do is take the x out front. So now we have log of 6, log of 20. And so now what we can do is put the log 6 over to the other side. So we have log 20 divided by log of 6. And so now we can just plug it into our calculator. Whoops. Log 6. And so we get 1.67. We're going to leave it there. All right, and it becomes slightly more complicated, but just really one extra step. If you have an exponent with like x plus 1 or x minus 1 or plus 7 or whatever it is. So let's go ahead and try this one out. So we're first going to do the exact same step. So log of 4 to the x minus 1 equals log of 80. So I just took a log of both sides. Okay, then I'm going to take the x minus 1 out front. Log of 4, log of 80. So yeah, I can just take the power out based off of the last unit, power law of logs. And then what we're going to do is move the x minus 1, or move the log 4 over to the other side. So we have log 80 divided by log of 4. So now what we're going to have is we're going to move the minus 1 over, so it's going to become a plus 1. So 1 plus log 80 divided by log of 4. And so that equals, so now we just plug in our calculator, 1 plus log 80 divided by log of 4. So now we get 4.16 and a whole bunch of numbers. All right, so hopefully those 4 questions are relatively straightforward and make a little bit of sense to you. Now we're going to try a word problem, because that is really when we are most likely to mess things up. So I'm going to zoom out just a tad so we can actually see the word problem. Actually, I'm going to rearrange it so it's easier to see even if we're zoomed in a little bit. Yeah, there you go. All right, so Jimmy invests $2,700 into a bank account that pays 5.6 per year, compounded annually. So first of all, before we move on, I just want to write down the equation for compounded interest. So I guess amount equals principal 1 plus interest rate to the n. So it looks like this. So anyways, algebraically determine the number of years until Jimmy's investment is worth at least 4,500. So we could simply just plug in two different equations into our graph, make a graph, and see the intersect point, and that would work just fine. But we want to solve this a little bit more algebraically. Because it's a written response, we have to do that. So we have to listen to what the question says, and it says algebraically. Okay, so with that said, let's try to solve this algebraically. So let's put in the numbers that we know first. The amount we want at the end is 4,500. The principal, that means the starting amount, is 2,700. And we have 1 plus the interest rate, which is 0.056. And it's compounded annually, so that's just tells us it's 1n, or just n. Okay, so how many years until it is worth at least 4,500? At least is an important word, so we're just going to notice that. And let's rearrange this and simplify it a little bit. So 4,500 divided by 2,700 equals 1.056 to the n. All right, so now at this point what we can do is we can take the log of both sides. So log of 4,500 divided by 2,700 equals the log of 1.056 to the n. And now what we're going to do is take the n out front. So everything is the same except we're using our power law in order to move the n. Yeah. So the n comes out front, so we just have 1.056 in here. And so now what we can do is we're at the same point that we were at before in our regular questions. We're going to divide both sides by log 1.056. So we're going to start with log, and this is where, well, I'm going to rewrite it all out. I was going to say I can simplify it, but let's just rewrite it all out. Divided by log 1.056. Okay, now I want to simplify it just a little bit for myself before I plug it in my calculator. I normally wouldn't write this step out because it's not really that important, but hey, I'm doing it anyway. Divided by 27, and that could even be simplified more. Divided by 9, so it's 3. This one has 5. Right? 5 over 3. Is that the same answer? So log 45 divided by 27 should be the same answer as log 5 divided by 3. Yeah, it is. Okay, anyways. So I simplified it correctly. So anyways, 5 divided by 3, and then divided by the other log, which is 1.056. And so that is 9.37. So that's how many years it is until it's worth that amount exactly. Probably you could generally leave your question or your answer as that, but at least that means we're going to have to round up. If it was 9 years, it would not work. So this is the best answer because it's at least that much amount. So if you did 10 years, it would for sure be that amount. All right, and you can double check your answer. You could verify by plugging this whole thing back in and seeing what it gives you. So let's do that right now. 2,700 times by 1.056 to the exponent, and then we do 10 years. Will it work? Yes. If it's 10 years, it'll be more than. So that works. All right. I hope this video helps you understand 7.4 and solving exponential equations using logs. Good luck.